All right, guys. Good evening, all. Good evening, all. How are you all doing? Please, if you are active, indicate that you are active. So we are starting now. If you are active, please indicate that you are active. We are starting immediately. We are starting now. Please indicate if you are active. Please indicate. Please indicate you are active. If you are active, if you are online, please indicate. We are starting now. Please indicate. Indicate. I hope the camera is clear, right? I hope it is visible. Please indicate that you are active. Indicate that you are active. Let's keep on sharing the group link to your departmental platforms. Keep on sharing the group link to your friends. Let's connect many people to this online class. Let's connect them. Let them join. Let them join. Connect them. Connect people. Connect people. Connect people. Connect. 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 Connect people. Connect people. 4 persons online. 4 persons online. Okay, I'm seeing Ugochukwu. I'm seeing Young Evangelist. You are welcome. I'm seeing Austin. Austin just joined, right? Please, let's indicate our presence. Let's indicate. Let's indicate. Let's go. Let's go. Let's go. Let's go. Have you guys shared the link? Have you guys shared the link? Please share the link to your various departmental platforms. Share the link to your friends. Share the links to as many people you can, many groups. If you are in 5 groups, keep on sharing the group link. If you're in your faculty group, share the group link to your departmental, your faculty group, any group. Okay, let's connect with other students. Let them come online. All right. Okay. We are starting right away. We are starting right away. Today, I'll be concluding on friction, right? Concluding on friction today. Today, I'll make sure we conclude on friction. Then we'll look at dynamics of connected bodies on an inclined plane. Dynamics of connected bodies on an inclined plane using the pulley system. How to find the acceleration of a body when we have a body on an inclined plane, okay, connected to a pulley system. All right, so let's keep on sharing it. Let's share, let's share, let's share, let's share. All right, I'm saying 12 persons online. I want us to get to 20 people online, 20. At least if we can get to 20 persons online, then we can start. 12, 12, 12. That means 8 more, 8 more, 8 more. 8 more people, 8 more people. Let's keep on sharing. Let's keep on sharing. All right. Okay, we are starting quite very now. We are starting now. We are starting now. We are starting now. We are starting now. Let's share. Let's share. Let's share. All right, guys. Good evening, everyone. How are you all doing? For those of you who just joined us, you are welcome to EMI-BRAIN online class. This is actually an exam preparation tutorial. All right, for students in IMSU, for students across other universities in Nigeria. All right, we can as well share this group link to other students in other universities. If you have any friend in UNN, UNIBEN, UNIZIC, any university at all, just share the group link. Let them connect with us. All right, this is a global classroom because we are online. This is a global platform. Okay, And what you'll be learning tonight will be defining, because we'll be solving problems regarding what we have studied, what we have learned in our previous uh, classes on friction. Okay. All right. Please, let's keep on sharing. Let's keep on sharing to know how many persons who are online. Okay. Let's keep on sharing. Let's keep on sharing. I want to believe that the board is clear, right? Hope it's clear. It's not blurring. It's not blurred, right? Hope it's clear. All right, we are starting now. This is already 6 minutes gone. Okay, in our previous class, we discussed about friction. We talked about friction, and we were able to establish what friction is all about. Okay? We're able to establish what friction is all about. A minute, let me get my app ready. Let me get my app ready. If you're online, please indicate that you're online. If you're online, please indicate that you're online. All right. Are you guys hearing me from there? Are you guys hearing my voice? All right, guys. In our previous class, yesterday, we talked about friction. The first class, we have defined what is friction, types of friction, advantages of friction, disadvantages of friction, method of reducing friction. So many things we discussed under the concept of friction, right? Then we also talk about work done by the applied force and work done by the frictional force. That the applied force will always do a positive work, which causes a forward work, a forward acceleration, right? Then the frictional force will always do a negative work. Then yesterday we were able to establish frictional force along an inclined plane, right? And we saw several cases on this in this class, and we be solving some exercises from your textbook. So please, for those of you who are in Imo State University, get your physics textbook, because we want to solve all the exercises under friction. Okay, so that in case maybe um IMSU wants to set any problem, they will not go beyond these questions we'll be solving tonight. So get your textbook ready. We'll be solving them one after the other. Then once we are done, we then go into dynamics of connected bodies in on an inclined plane. Dynamics of connected bodies on an inclined plane. That will be the last class under friction. Then after this class, we go into another topic in physics, right? Then tomorrow we look at mathematics or chemistry. Are you there? But today our focus will be on friction. Yesterday, we talked about friction along an inclined plane. That if we have an inclined plane and a body is placed on this plane, right? That the weight of this body will always act what? Downward. The weight is what? Is always acting downward. Like you are seated on a surface. Your weight is always acting downward, right? Then we say that this weight here can be resolved into two components. Okay? Then along this plane, we have our angle of what? Inclination called theta. Theta is called the angle of inclination. This body has a certain weight. This is a body here, a certain weight, which is called what? Mg. This mg can be resolved into two. There's a force that we discovered yesterday that is perpendicular to the surface of this body, right? We call that force what? The normal what? Reaction. The normal reaction, or the normal force, or the pressing force, right? Or the pressing force. We then say that this force can be extended downward, right? Because it is called what? The pressing force, right? The force pressing the body on the surface of what? Of this plane shape. Okay? This is the force pressing the body on the surface. And this force here that presses the body on the surface is called the normal what? Reaction. And normal reaction is equal to what? Mg cos theta. We say that the weight is here, right? Weight is equal to what? Mg, right? The weight is also acting downward. If we have the angle of inclination here, yesterday we also discovered that there's an angle from here to the vertical. This is a vertical line, right? That is perpendicular to the surface, okay, of this plane. And that vertical line is referred to as what? Normal what? Reaction, which is being resolved as what? R equals to mg what? Cos theta. Then there's a force here called what? Fg, which is the force responsible for sliding. That for a body to slide down, the force responsible to cause the body to slide along this plane is what? Is mg sine theta. This is the force responsible for sliding. Then the force responsible for pressing down the body is what? The normal what? Reaction, right? Then the weight is acting downward, which is mg. Then we say that if we are dealing with a rough surface, that means we are neglecting friction. That implies that there's no frictional force that opposes the motion of this body as this body is sliding down or going up, right? But if we are dealing with a rough surface, it means that there must be a force of opposition, which is called the frictional force, right? Then when the body is in motion, we say that the frictional force becomes what? Kinetic what? Frictional force. I'm not going into this again. I'm just trying to establish a concept here because I'll be needing most of these parameters I just explained now to solve all the exercises in your textbook. All right. Yesterday we looked at several cases of how a body acts along what? The inclined plane. We saw a case where a body is sliding down on a frictionless surface. We saw a case where a body is sliding down on a non-frictionless surface. We also saw a case where a body is being pushed up by a force called the applied force. We also saw a case when a body is being pushed down by a force called what? The applied force. When a body is being pushed down by a force called the applied force, we call that force down, right? We saw a case of this, right? Then we say when the force is applied, that force is called what? Force up, right? And all that. Please, for those of you who just joined us in this class, go back to yesterday's class. Yesterday's class is still in the YouTube channel. You can always go back and revisit, okay? Because there's no need of us going back again and to explain all of these concepts, all of the cases we analyzed yesterday. We saw many cases. In fact, we saw a case whereby the applied force, whereby our Fg is equals to what? Fx what? Maximum. That's Fk rather. Yeah, Fs maximum. That when Fg is equals to what? Fs maximum, right? the body will just begin to what? To slide down. At this point, when the body just begins to slide down, the angle formed between on this plane is called the angle of what? Repose. The angle of what? Repose. The angle of repose. It's also called the maximum angle. The maximum what? Angle. The angle of repose is the angle obtained when Fg is equal to what? Fs what? Maximum, right? When Fg is equal to Fs maximum. That angle form is called the angle of what? Repose. Now, what do I mean by the angle of repose? Fg, we know is what? Is mg sine theta, right? Is equals to Fs is given as mu x mg cos theta, right? So from here, mass can cancel mass. Gravity can cancel gravity. We are left with what here? Sine theta equals to mu x cos what? Theta. All right? From this expression we have here, we can decide to divide both sides by cos theta. By what? By cos theta. By the time we divide by cos theta, over what? Over cos theta. Cos theta will cancel cos theta, right? We are left with what? Mu x. Mu s. The ratio of sine to cos is given as what? Tan what? Tan theta, right? So mu s equals to what? Tan theta. This angle here is called the angle of repose. Now, how do we find the angle of repose? Is by saying that theta equals tan inverse. Angle of repose, which is theta, equals tan inverse of what? Of our mu what? S. Okay. If mu s is 0.1 or 0.2, any value got in here is called the angle of repose. And that angle is obtained when Fg equals to what? Fs. And when these two forces are what? Are equal, the body will just begin to what? To slide, right? The body will just begin to slide. But when Fg is greater than what? Is greater than what? Fs. The body will start sliding. At that moment, the angle form is not called the angle of repose. It's called the angle of inclination. The angle of what? Inclination. Now, let's solve some problems now. Let's solve some problems. I want us to remember there's the last law of solid friction that will say that frictional force, right, is equals to what? Mu r. Mu r, right? Mu r. Don't forget that we say that our normal reaction for an inclined plane is given as mg cos theta, right? While Fg is given as what? Mg sin theta, right? From here, we can determine the formula for finding the frictional force. General frictional force becomes what? F equals our mu, okay, times the value of R here is what? Mg cos theta. Here becomes mu mg cos what? Theta. Generally, frictional force for an inclined plane is defined as mu mg cos theta. If we are dealing with static frictional force, here will be Fx, right? Here will be what? Mu x mg cos theta. If we are dealing with kinetic frictional force, here will be Fk. Here will be what? Mu k, right? Just like that. Please take note of this. The first question we have in our list says that. The first question, please, if you're online, please indicate that you're online. If you are following, indicate that you are following. Some are saying, sir, I don't understand. If you are here yesterday in our class, you will have understand what I'm saying, okay? Please ensure you go back to the previous class. And you guys should please do me a favor. Be consistent in this class. Be consistent. Any class you miss will affect you the next day. Online class, I will not be able to have time trying to repeat myself all over and all over again. Please, if you don't understand anything, indicate that particular thing you don't understand in the comment section. Indicate it. Don't just say that I don't understand. Just indicate it. Anything you know you don't understand, indicate it. Be specific so I can throw more light to that thing. Or all right, I can throw more light to that thing. Anything you don't understand, please indicate in the comment section. It's very important. All right, please indicate. Okay. Omar Brown says, sir, I don't understand. Please indicate where you are confused so I can throw more lights to it. Okay. Now, just note that frictional force is given as what? Mu mg cos what? Cos theta. Now, in your textbook, let's solve the problem we have in your textbook. I am so certain that your exam, they will set an equation from this exercise. IMSU exam is always from your textbook. Sometimes they can just pick an example or they can just go to the exercise and pick an example. The first example or the first exercise we have says that a driver attempting to negotiate a flat highway. A driver, I will not be writing all, but let me just write this. Attempting to negotiate a flat highway. Highway curve that has a radius R. That has a radius R. Needs a maximum speed Vm so that the car will not skid. So that the car will not skid. Then we are told that considering mu x, show that Vm maximum speed is equals to square root of mu x rg. This question might appear in your exam. All right, so please take note of this. We are told that a driver attempting to negotiate a flat highway curve. A driver attempting to negotiate. The driver is here attempting to negotiate, meaning that the driver needed to what? To move in a circular path. A flat highway curve. Are you seeing the concept here? That has a radius R. The radius of this curve is what? Is R. Now we are told that it needs a maximum speed. It needs a maximum speed so that the car will not skid. Skidding means so that the car will not move away from this negotiation. Okay? Then we are told that considering mu x, show that maximum speed is equal to what? Mu x r what? Mg. Now please take note. One of the way of preventing friction, okay, is by banking of what? Of roads, right? One of the way of reducing friction is banking of road. What does banking of road? The essence of banking of road is that when the car wants to negotiate a flat highway curve, the car will not skid off. And for a car not to skid off, there are two forces that must balance each other. Now listen, when the body moves in a circular path, there is a force responsible for that movement, which is called the centripetal force, the inward force. As the car is negotiating with the centripetal force, before the car negotiates, at this point where the car negotiates, the static frictional force must be equal to the centripetal force. Don't forget that As a car is negotiating around its curve, there is a force responsible for that circular motion, which is called a centripetal force. Okay? For this car not to skid off, it means that the static force, frictional force, okay, must be maximum and must be equal to what? The centripetal force. Please take note. For a car not to skid off, note. For a car not to what? Skid off. Centripetal force, Fc, must be equal to what? Static maximum force. Or we can say that centripetal force must be equal to limiting frictional force. Limiting simply means what? Fx what? Maximum. Right? Good. Don't forget that centripetal force is given as mass times b square over what? R. Centripetal force formula says what? mv square over what? R. Equals to what? Somebody. Fx maximum. We say that frictional force is equal to what? Mu R, right? So if I'm dealing with what? Static frictional force, Fx will give us what? Mu x what? R. From here, we are even told that considering mu x, meaning that the force that must balance the centripetal force is called what? Somebody? The static frictional force. So we are considering it. It was given there. Okay. Then show that this equals to this. Now, Fx maximum is simply what? Mu x R. Don't forget that R is equals to what? Mg for a body moving along the horizontal surface. Okay? R equals to what? Somebody? Mg. So from here, we can say that mv squared over what? R is simply equals to what? Mu x what? Mg. At this point where these two forces are equal, the speed there is simply what? The maximum of speed. So we have mv square m, right? Over r equals to what? Mu x mg. Mass can cancel out mass. Okay? If mass cancel out mass, we are left with what? Vm squared over what? R. All equals to what? Mu x what? Mu xg. From here, we can cross multiply, meaning that Vm squared times 1 is what? That will give us our Vm squared, maximum speed squared, equals to what? Mu x rg. So if that is the case, to take off this square, we have to square root both sides. By the time we square root both sides, that implies that our maximum speed becomes what? Square root of what? Of mu x what? Rg. Please take note of this. We have been able to show it. Question says show that Vm maximum speed equals to what? Mu x Rg. One thing you should learn from this is that for a car to negotiate a highway curve, okay, the car needs a maximum speed. That maximum speed can only be obtained when two forces balances each other, which is what? Fc equals to what? Fx maximum. Fc is called what? Centripetal force, right? What's our Fx? Which is our mu x what? R. Where R is what? Mg. By the time we cancel out mass from here, we can make our V as one subject. Then our Vm becomes what? Square root of what? Mu x Rg. That is how simple this question is. And this question will appear in your exam. I'm so certain. So please take note of this. All right? Whenever I say it will appear, just take note and write that I said it will appear. All right? Please take notes. If you are following, say I'm following somebody. If you are following, say I'm following. Say I'm following. Say I'm following. Omar Brown, are you getting it now? Are you following now? Do you understand what we are doing here? Let's keep on sharing the link. Let's keep on sharing the link. Let's keep on sharing the link. Question number 2. 11 points. 11.2 or what? Question number 2, yes. Number 2. Please take your textbook. Make sure you have your textbook with you, because I will not be writing all. Make sure you have your textbook with you. I will not be writing all. All right. Question 2 says, a crate rests on the floor of a truck that is traveling up a hill at an angle of 15 degrees. A crate rests on the floor of a truck that is traveling up a hill at an angle of 15 degrees. If the coefficient of static friction between the crate and the truck floor is mu x equals 0.4, what is the maximum acceleration the truck may have if the crate is not to slip? If the crate is not to slip. Let's take it one after the other. The question says, a crate rests on the floor of a truck traveling up a hill. I have a hill here, right? Then there is a truck traveling upwards this hill, right? And we are told that the angle of inclination is simply what? 15 degrees. This is the truck here. Okay? This is the truck here traveling up a hill. This is my direction of what? Of motion, right? Direction of motion or of acceleration. This is our truck. This is our truck traveling up a hill. Is going up a hill, right? Let's say point A, point B, and point C. Okay. A crate rests on the floor of a truck. That means we have a crate here. There's a crate here resting on the floor. This is the truck here. This is the crate, right? This is the crate. This is the crate here, resting on the floor of a truck, traveling up a hill. If the coefficient of friction between the crate and the truck, if the coefficient of what? Friction, static friction between the crate and the truck, meaning that what is holding the crate on the truck is what? The static frictional force. The static what? Frictional force. If there is no frictional force, if this truck surface is a smooth surface, this crate will have slipped, will have fallen off as this truck is traveling up the hill. So because there's a frictional force on this truck, this is what is responsible for the crate not to work, to slip. We are now told that coefficient of static friction between the crate and the truck is 0.4. Is 0.4. Then the question says, what is the maximum acceleration the crate may have if the crate is not to slip? What is the maximum acceleration this truck will have if this crate will not slip? Don't forget that when we look at a an inclined plane, and we have a body resting on the inclined plane. We say there's a force responsible for sliding. That this force is always there all the time. And the force here is given as what? mg, right? Sin theta. This is the force responsible for sliding. That means I have this force here responsible for the torque to slide down, which is what? Somebody Fg equals to what? Mg sin what? Sin theta. Are you there? Now, we are not told that there's a frictional force or whatsoever along the plane, but we are told that the frictional force holding the crates on the truck is what? Somebody static. We are only giving reference to what? The static frictional force between the crate and what? And the truck. That means that as this truck is going up the hill, static frictional force is also going up at the same time. Meaning our Fx is going up at the same time. Static is just there, is a force that keeps a body at rest, or a force that acts on the body at rest, not in motion, right? So for this crate to remain on this truck, it possesses what? Static. That means as the truck is going up, static frictional force is also acting in the same direction. So if Fx is acting in the same direction, that means Fg is acting against it. Don't forget this diagram. Let me explain some things here. Let's say, for example, I have a body accelerating. As this body is accelerating, it means that the body is going toward this direction, right? Let's consider that this surface is a rough surface. So that means as the body is going upward along this plane, kinetic frictional force is acting what? Down, right? Because this force here, our Fk, is an opposing force, opposing the motion of this body as this body is going up. Am I communicating here? But if you look at this now, the crate is not moving, but the truck is one moving. And we are told that the force between the crate and the truck is what? Is static. Since static force is not moving, it's just between the crate and the truck. That means as this truck is going up, Fs is also going up. Unlike this diagram, as this body is going up, Fk is opposing it. As this body is going up, Fs is not opposing because Fs is between the crate and the truck. Fs is not between the truck and the surface. If Fs is between the truck and the surface, that means that this Fs will be acting downward. But because Fs is just between the crate and the truck, that means as the motion is upward, Fs is also upward. That means that Fs is doing the positive work because it is acting in the direction of what? Of motion or acceleration. But Fg is acting against it. So that means for what we learned yesterday, it means that the sum of all forces, since our Fs is in the direction of motion, it becomes what? Positive Fx. Since Fg is against it, is moving in a different direction, or is anti-motion, is not moving in the direction of motion, it becomes what? Somebody minus what? Fg, which is equal to what? Ma. You know, we are asked to find the acceleration, the torque we use to move for this crate not to slip, which is our what? A. But don't forget that we have already defined our Fx to be mu x mg cos theta, while Fg is also defined as what? Mg sin what? Sin theta. So I can put all of these force in this main equation here, right? Then if that should be the case, that simply implies that this becomes what? Sum of all forces becomes our Fs is mu x mg cos theta minus our Fg is mg sin theta equals to what? Ma. So from here, we have that between these two, what is common is mg. So I can say mg is common in brackets mu x cos what? Cos theta minus sin what? Sin theta equals to what? Ma. So from here, mass can cancel mass from here. We are now left with what? Acceleration equals g mu x cos theta minus sin theta. Here, g is giving us about 9.8 meter per second squared. So let's put our value. A becomes 9.8 times our mu s is giving us what? 0.4 cos our angle of inclination is what? Is 15 degree minus sine 15. Okay, let's evaluate this together. Let's evaluate together. So acceleration becomes 9.8 times 0.4 times cos 15 is about 0.9659 minus sine 15 is 0.2588. So acceleration becomes 9.8 times. Let's evaluate what we have here. 0.4 times 0.4 times 0.9659 minus 0.2588. Here we have times 0.1276. Then times 9.8. Let's go again. 9.8 times 0.1276. This is about acceleration equals to 1.25 meter per second square. 1.25 meter per second square. This is how simple this question can be. I hope it's clear. Please, if you are following, indicate that you are following. Indicate that you are following. Indicate that you are following. If you are getting it, please indicate. Indicate, 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 indicate. Awesome. Right down. I'm following. I'm following. Okay. Indicate, indicate, indicate. The next question is the third one. The third says, let's clean the board. Okay. The third one says, I hope you are all with your textbook, right? By now, you should have your material with you. A block slides down an inclined plane of slope angle theta with constant velocity. It is then projected up the same plane with an initial speed vi. How far up the plane will it move before coming to rest? They now give us the answer, that the answer must not exceed this. The answer that was given is vi squared, meaning initial velocity squared, divided by 4g sine theta. This is the answer given to us. The question says again, a block slides down an inclined plane of slope angle theta with constant velocity. It is then projected up the same plane with an initial speed. How far up the plane will it move before coming to rest? We have two conditions here. The first condition, or the first statement here, says a block is sliding down with a constant velocity. Don't forget, yesterday I was able to establish that when a body is sliding down with a constant velocity, or when a body is moving with a constant what? Velocity, that means there is no acceleration. It means that acceleration of the body is equal to what? Zero. Are you there? That means there's no force acting on the body. All right? Then number two, we are now told that after sliding, it is then projected. It is then projected up. The force was, it was sliding down with a constant what? Velocity. Full stop. It is then projected up the same plane with an initial speed. They gave us vi as the initial speed. Then we are told that how far up the incline will it move before coming to rest. And we are told that the answer is what? Is this, right? Let's look at this question. The first is projection of the plane, or projected, Abi. Okay, sliding down. Yeah, that's the first one, is what? Sliding down, okay? Sliding, rather. Sliding down what? The what? The plane. At what? At constant velocity, right? At constant velocity. When the body is sliding down, if we have this, the body is sliding down, meaning that, and we are told that the angle here is what? Theta, right? The body is sliding down. Here we have Fg, okay? Here we have our Fk. Don't forget, here we have Fk. For a body sliding down the plane, that means this body is obeying the force of gravity here. That means our Fg is positive because the direction of motion is this way. This is my direction of what? Of motion. We have two forces along the plane. We have Fg and we have what? Fk. Fk is the frictional force that tends to oppose the motion of the body as the body is sliding down. Now, between these two forces, which of them is moving in the direction of motion? Definitely is what? Is Fg. But we are told that the body is sliding down at a constant what? Velocity. That means that Fk must be equal to what? Fg. But let me show you why. Sum of all forces, right, will then be what? Fg plus Fg, because Fg is moving in direction of motion, minus what? Fk, all equals to what? Ma. Since the body is sliding down at constant what? At constant velocity, that means my acceleration is equal to what? Zero. So sum of all forces, yeah, that act on this body is, which is Fg minus what? Fk, will then be equal to what? Mass times m times 0 is what? If I'm to put 0 here as my acceleration, That means the total force here is what? Is 0. By the time we move this minus Fk to the other side, that means Fg is equals to what here? Fk. Right? Okay. If this is true, Fg we know is what? Is mg sine theta, which is equals to Fk is mu k, right? Mu k mg cos what? Cos theta. I'm heading somewhere. All right? I'm heading somewhere. Let's analyze the sliding down the plane. Then we'll look at the second case, which is projected up. The first case was that the body is sliding down at a constant what? Velocity. Then the second case is projected. So let's exhaust everything we have here under sliding down. Now we are seeing that Fg equals to Fk for a body to slide down at a constant what? Velocity. So from here, mass can go with mass. G can go with what? G, okay, which is our gravity. Here we have what left? Sine theta, right? Now we are left with sine theta equals to what? Mu k cos what? Theta. Right? From here we can determine the value for mu k. Let's find the value for mu k, okay? We can divide both sides by what? How do we get mu k? To solve for mu k, it means I'll divide both sides by what? By cos theta, right? Okay, over cos theta, over what? Cos theta. So that implies that cos theta, we go with cos theta, right? And that will give us what here? Our mu k equals, the ratio of sine to cos is what? Is tan what? Tan theta. Let's call this equation what 1. So let's look at the second case for projected. Projected what? Upward. Upward or up the plane. When the body is projected up the plane, in this case, there's nothing like at constant what? Velocity. We are only told that it is then projected up the plane with an initial speed. That means it has an initial speed, no longer at constant what? Speed, right? So for a body to be projected upward, let's restructure our diagram. Let's look at it here. For a body projected upward, I have this body here. But in this time around, the direction of motion is acting this way. Motion is acting upward. Motion is acting upward. I'm coming. Let me make sure that the YouTube is working. Hope you guys are all following. I hope you are all following. I hope you are all following. Someone is asking, sir, which page? Please take friction in your textbook. Friction in your textbook. Friction in your textbook. The textbook I'm using here is not the same with yours. Okay, this is the old textbook. So take your textbook. But all the exercises here are also in your textbook. So take. Okay, now for upward, Fg is always downward. Don't forget, this force is always downward. It is the force responsible for sliding. Now, we are not told that if it's being projected upward, frictional force will definitely act this way. It means our Fk is acting against it because the body is projected upward. As the body is going upward, frictional force is acting downward. So frictional force is acting down, not just only frictional force that is acting downward. The other force that is also acting downward is what? Is Fg. So that means that sum of all the forces acting along the plane will then be what? Minus Fg minus Fk, all equals to what? Ma. I hope this part is clear because the motion of the body is upward. So Fk and Fg, they are not moving in the direction of motion. So that means they'll be negative. Is that clear, somebody? Okay. But don't forget that this will give us what? Yeah? Our Fg is minus mg sine theta. Then Fk is what? Minus mu k mg cos theta equals to what? Ma. Fg is mg sine theta. Fk is minus mu k mg cos theta equals to what? Ma. I believe that I can now clean this part, Abi. Let's clean and finish up. Let's clean and finish up. Okay. Now watch. Between this, what is common is minus mg. Minus mg. Okay, it's common in brackets. We are left with what? Sine theta minus mu k cos theta equals to what? Ma. From here, mass can cancel out the mass. We are left with acceleration equals to minus g in brackets sine theta minus mu k cos what? Cos theta. Okay. Let's go back again, of course. So here should be plus. Thank you. Plus. We have already factored out minus. So here should be plus. Don't forget. We are factoring out minus mg. Minus mg. So here should be positive. Right? Here should be positive. Okay. But recall that mu k is equals to what? Tan theta. I can put the value of my mu k as tan theta here. It means my acceleration is equals to minus g sine theta plus mu k is what? Is tan theta times cos theta. Then acceleration becomes minus g in brackets sine theta plus tan theta is simply sine theta over what? Cos theta times what, somebody? Cos theta. Are you following? Tan theta is the ratio of sine over cosine, right? This is over what here? 1. So cos theta can go with what? Cos theta. We are left with A equals to what? Minus G in brackets sine theta plus, here we are left with what here? Sine what? Sine theta. Sine theta plus sine theta will give us 2 sine theta. So acceleration equals to what? Minus G in brackets 2 sine what? Okay, let's just add up. This plus this is 2 sine theta, right? Times minus G will give us what? Minus 2G. Or let me go this way. Minus G in brackets 2 sine theta, which is also equals to what? Minus 2G sine what? Sine theta. So A equals to minus 2G sine theta. But we are asked to find that if it is projected up the same plane with an initial speed, how far up the plane will it move before coming to what? To rest. How far up the plane will it move? How far up the plane, will it what? Move. Will it come to rest, right? Will it come to rest? Is that what I use there? Will it move before coming to rest? Will it move before coming to rest? When a body comes to rest, final speed is equals to what? 0. Don't forget. When the body starts from rest, initial speed is 0. But when a body is coming to rest, is coming to the final state, to rest simply means our final speed must be equal to what? To 0. So let's finish up. We are almost done with our calculation. How long will it take before coming to rest? The word how long or how far rather will it take before coming to rest simply implies that we are asked to find our distance, right? We have to find our distance. Recall, we have what we call equation of what? Motion, Abi? Equation of motion. We have V equals U plus AT. We have X equals UT plus what? Half AT squared. We also have V squared equals what? U squared plus 2AX. Look at this. Definitely I cannot use this to solve because I don't have my distance or displacement. Number 2, I can't solve with this because I don't have time. Although we have our distance, right? How long means distance. But because we don't have time, we cannot solve with this and this. But this is the best formula to use to solve from the equation of motion. We can be able to determine the value of our distance from here, knowing that V is already what? 0, right? Then the value of our acceleration we got is what? Minus G, minus 2G sine what? Theta. So from the equation of motion, we are going to be using V squared equals U squared plus what? 2AS. But from the textbook, they use VI as initial speed, right? They use VI as what? Initial speed. That means VF will not be what? Our final. So I can convert this to be what? VF squared, right? Plus what? VI all squared plus 2AS. This is same as V squared equals to what? U squared plus what? 2AS. V here means final. U here means initial. VF means final velocity. VI means what? Initial what? Velocity. Now let's solve together and see if we are going to arrive at the same answer. So since we say that our V final velocity is 0, Abi, so here becomes what? 0 equals to our VI all squared plus 2 times acceleration we got is what? Is minus 2G sine theta. Minus 2G sine theta. All multiply with what? Distance. Okay, so here becomes our 0 equals rather VI squared. Minus 2 times 2 is what? Minus 4G sine what? Theta times distance. So from here, I can move this to the other side, right? Here becomes minus VI squared equals to minus 4G sine theta times what? Distance. We only move this, then the sign becomes minus. So minus can cancel minus. Our aim is to find distance, how far. So the next is to divide both sides, right? So divide by both sides by 4g sine theta. 4g sine what? Theta. So here becomes, by the time we divide, that will give us what? Yeah? Our distance equals vi all squared divided by 4g sine theta. Final expression. Final expression. I hope it is not lengthy. All right? Please ensure that you go back to this video to watch from the beginning how we're able to derive this. All right? So VI represents our final speed. Now we have seen that our answer corresponds with their own answer from the textbook, right? The next question, please, if you are following, indicate you are following. If you are following, indicate you are following. Someone is asking, why is FK acting downward? Of course, as the body is projected upward, that means that the body possesses what? Kinetic frictional force. If a body is going up, frictional force is always acting down. Frictional force, the job is to slow down or to oppose motion. So if a body is going up, frictional force Fk must come down. That is just the reason. All right. All right. Let's move on. All right. Hello, guys. Please forward the group link. Keep on forwarding. Keep on forwarding. Let's keep on forwarding. Let's keep on forwarding. Let's keep on forwarding. Forward it again. If you have done that before, please forward again. If you have done that before, forward again. Forward again. Forward again. Forward, forward, forward. Okay? Please, if you have done that, forward. Let's keep on sharing. The fourth question. The fourth question. If a force F equals 19 Newton, if a force F equals 90 Newton, parallel to the surface of a 20-degree inclined plane, we push an 8-kilogram block up the plane at constant speed. Question 1 says, what force parallel to the plane will push it down at constant speed? Question 2 says, what is the coefficient of sliding friction? I guess the question should be the other way around. Let me repeat again. If a force F equals 90 Newton, parallel to the surface of a 20-degree inclined plane, we push a 8-kilogram block up the plane at constant what? Speed. The first question should be, what is the coefficient of sliding friction? That's the first question. Number 2, what force parallel to the plane will push it down at constant speed? Okay, we're going to look at this question now. Now, let's look at it together. We are told that we have an inclined plane here. right? If and the body is kept on the inclined plane, the angle here is 20 degrees. We have a body here. The mass of the body is 8 kilograms. Yeah, don't forget that we always have what? Yeah, Fg. If a force of 19 Newton, that means I have an applied force up, 19 Newton. If a force of 19 Newton parallel to the plane, right? Parallel to the plane of 20-degree inclined plane rather, we push a 8 kilogram block up the plane at constant speed. We have to find what is the coefficient of sliding friction, meaning what is our mu k? What is our mu k? That means that this surface is simply a rough surface. It's simply a rough surface. If we are applying a force to push a body up the plane, so that means that the motion of the body is this way. I have always said this, that before you start solving any problem, first of all, identify where the motion of the body is tending towards. So since we have a force of 19 Newton applied on the body, okay, that means the body is going up the plane. The motion is this way, all right? So that means that frictional force will be acting downward, which is what? Our Fk. It's acting downward, is our Fk. Excuse me, let me check if there's lights. Okay, let's proceed, guys. Let's proceed. If you are following me, say, I am following. Hope what I just said now is clear. We are told that, I repeat again, I want you guys to understand this question. If a force F equals 19 Newton, parallel to the surface of a 20-degree inclined plane, we push a 8 kilogram block up the plane. So this force is pushing the block up the plane. So that means that the only force that is acting in the direction of motion is the applied force, right? Okay. This also means that frictional force Fk and Fg are acting against it. So to solve for this, the sum of all forces will then be the applied force or force up, right? Minus Fk minus Fg, all equals to what? Yeah, Ma. But we are told that this force parallel to the plane will push a 8 kilogram block, right, up the plane at a constant speed. That means our force up, the body is being pushed up the plane at a constant speed. And what did I say? That when we have a constant speed, since the body is moving with a constant velocity, at constant speed, acceleration equals to what? 0, right? Meter per second. It means there is no acceleration. It simply means the sum of all these forces will then be what? Force up minus what? Fk minus Fg equals to. By the time we put our A as 0, what is mass times 0? That will give us 0, right? Okay. Now let's evaluate further. So that will give us our force up minus Fk is simply mu k mg cos theta. Don't forget, it's mu k mg cos theta minus Fg is mg sin theta, all equals to what? 0. All equals to 0. So from here, our aim is to find mu k. That means I'm going to make the whole of this to stand alone as subject of the formula. So that implies that minus mu k mg cos theta. When we move this to the other side, it becomes what? Plus, right? Is equals to what? Mg sin theta minus force up. Minus force up. Okay, let's evaluate further. From here, I can divide both sides by minus. Right? This will give us what here? Mu k mg cos theta will then be equals to minus mg sin theta plus force up. Is that not? We divide both sides by what? By minus. Because I want to eliminate this minus sign here. So that will give us what? Plus mu k mg cos theta equals to what? Minus. When divided by minus and we have minus mg sin theta, this becomes what? Plus, right? Okay. Or I can rewrite this to be mu k mg cos theta equals to what? Force up minus what? Mg sin theta. Okay. All right. So let's look at what we are having here. Or from here, I will have just moved this right to the other side. Then we are left with force up minus mg. Okay, that is still the same thing. Our aim is to find mu k, right? So that means I'll divide both sides by what? By mg cos theta. Let's go. So divide both sides by what? By mg cos theta over what? Mg cos theta. So this can go with this. Mg can go with mg. We are left with what? Mu k equals to what? Our force up, which is 90 Newton, minus mg sin theta, all divided by mg cos theta. Now let's put our value and see what we are going to have at the end of the day. So our mu k is then equals to force up is 90 minus our mass here is 8 kilogram times 9.8 cos, sorry, sine rather. Sine, the angle there, let me confirm the angle of information, is 20 degrees. All divided by mass is 8 times 9.8 times cos 20. Now let's evaluate together with the help of calculator. Someone is saying it is not clear, sir, on the minus aspect. I think so. I know you. Okay, I understand why you're saying so. That's why I said just overlook here. From here, when you move this to the other side, here will be positive, right? On the other side, then we are left with what? Positive force up minus mg sin theta, right? And that will give us what we have here. Then we'll now divide both sides by what? By mg cos theta. And that gives us our mu k. Now let's punch our calculator to see what we're going to have at the end of the day. Let me clean here. Let's punch. What then is our mu k? Here we have 90 already, minus sine 20 times 9.8 times 8, right? This will give us 90 minus 26.8144, all divided by, let's evaluate, cos 20 times 9.8 times 8. This will give us about 73.6719. So our MUK is then going to be 90 minus 26.81, sorry, 44. This is going to give us 63.1856 divided by 73.6719. So our MUK will be this divided by 73.6719. And that will give us about, sorry, let me calculate again. 63.1856 divided by 73.6719. This will give us about 0.858. So by the time we approximate, our MUK is going to give us about 0.86. Okay, this is our MUK. Please take note of this, all right? This is our MUK. This is our MUK. Let's proceed from where we stop. Are you there, guys? So please take note of this. Take notes, take notes, take notes, take notes. All right. Please, if you are active, indicate that you are active. I hope it's clear. All right. Okay, sir. Now it is clear. Okay. Thank you for asking. Thank you for asking. So let's proceed. Let's proceed. Let's proceed. Let's proceed. If you are following, just indicate that you are following. Now let's solve the next question. Like I said, we are going to solve all the problems in this textbook. That is the aim of today's class. Each topic we look at, we solve all the exercises there. As many as we can attempt. As many as we can attempt. Okay, we're not done with the question, right? We're not done. We're not done. We have only gotten our MUK. Okay, I just noticed now. Our MUK is about 0.86, right? Okay. Then the B part says, what force parallel to the plane will push it down at constant towards speed? What force parallel to the plane will push it down at constant towards speed? That means if I have a body like this, right? The B part, listen, the angle is still 20, right? Degree. Then our mass, I guess, is 8 kilogram, right? We have gotten our MUK as 0.86. What force parallel to the plane will push it down at constant what? Speed. At constant speed. So that means that if I have a force here applied, I have our force down, right? Pushing this body down the plane. Don't forget that FG is always acting this way. Now, If a force is applied to push it down the plane, meaning the direction of motion is this way, right? Motion is this way. If motion is this way, there is a force that will act this way. Is that not? That force is called what? Our Fk. Don't forget, Fk is always acting against motion. So Fk is acting against it because we are applying a force down. Are you there? So what force we push it down the plane at constant what? Speed. Since they say at constant speed, speed, that means there is no acceleration, right? Our A is 0 meter per second square. Okay, so the sum of all the forces acting on this body. Now listen, Fd is acting in the direction of motion. Fg is acting also in the direction of motion. That means the only force that is acting against motion or against acceleration is simply our Fk, right? Okay, so that means that the formula becomes what? Fd be positive, Fg be positive. So we have Fg plus Fg minus Fk equals to what? 0. By now we know why we have 0 because the body is moving down with a constant speed. So mass times 0 will give us what? 0. So from here, we are asked to find the force parallel to the plane that will push it down. So I'm looking for Fg. So Fg here becomes what? By the time we move this to the other side, here becomes Fk minus what? Fg. So our force down becomes what? Fk becomes what? Mu k mg cos theta minus Fg is mg sine theta. Okay, let's put our value. Our force down becomes, what is common between these two is simply mg, right? In brackets, we are left with what? Mu k cos theta minus sine theta. Don't forget, as the force down is applied, force down is acting in the direction of motion. Fg is also acting what? The direction of motion or acceleration, but Fk is acting against. So both Fd and Fg are positive, but Fk is what? Negative. So that means the sum of all the forces must be equal to 0. Okay, and if that is true, and we have to find the force down, the force parallel that will push it down the plane, meaning what is our Fd? So Fd becomes, by the time we move this to the other side, here becomes what? Positive Fk minus what? Fg. But Fk is mu k mg cos theta minus Fg is mg sin theta. Already we have gotten our mu k to be 0.86. So that means we can look for the force down. The force down becomes, the mass of the body is 8. 8 times 9.8 in brackets. Our mu k is 0.86 times cos theta. Cos theta meaning cos 20 minus sine 20. Sine 20. And let's evaluate together. We have our force down equals 8 times 9.8. We give us, let's punch our calculator. Where is our calculator? So 8 times 9.8 is about 78.4. Then let's go into, we have cos 20 times cos 20, I'm coming, multiply with 0.86. This is about 0.8081 minus sine 20. Sine 20 is about 0.3420. So our first down is 78.4 multiply with, can we subtract this? Minus 0.8081. This is about 0.4660. So first down will become this value times 78.4. This is about 36.54 Newton. So the first down is 36.54 Newton. You can confirm this answer from your textbook. In the textbook, we are told that our MOK is 0.86. Then our first down is 36.54 Newton. Please confirm the answer. Confirm the answer. The answers are there, okay? The answer here says 36.37. Okay, possibly maybe the difference will have been from the approximation and all that. But our MOK is 0.86, so our answer is corresponding. Okay, now let's solve the next question. The next question. We are almost rounding up with this question. The next question in your textbook. If you are following, please indicate I am following. If you are following, please indicate that you are following. I hope they are following. All right. Let's continue. The next question says that a body of mass 12 kilograms is moving with a constant velocity of 5 meters per second on a horizontal surface. Okay. The coefficient of sliding friction between the body and the surface is 0.2. The question says what horizontal force is required to maintain the motion. Okay. Number 2 says if the force is removed, how soon will the body come to rest? How soon will the body come to what? To rest. That is question number. Okay, now let's look at this question together. We are told that a body of mass 12 kilograms, the mass of the body on a horizontal surface. The body is there. The mass is 12 kilograms. It's moving with a constant velocity. Our speed here is 5 meters per second, okay, on a horizontal surface. All right. Then the coefficient of friction was given as 0.2. Was given as 0.2. Then the question says that what horizontal force is required to maintain the motion? What horizontal force is required to maintain the motion? What horizontal force is required to maintain the motion? Now, I want us to take back our mind to the first class under motion along horizontal surface. That we say that if I have a body here, right, along a rough surface, right, that this body is being held by a static what? Static frictional what? Force, right? The body has a mass. The weight of the body is acting downward, which is R equals to mg, right? W rather equals to mg. While normal reaction R is equals to what? Mg. Is that not? Now, for the body to move, there is a frictional force that held its body, which is what? Static what? Frictional force. For a body at rest. For me to move the body from one point to another, I have to apply what? I have to apply a force. Force applied. Is that clear? Now, for this body to move, we say that for this body to just begin to move, we say that the applied force Fa must be equal to what? Fx. Abi? At that point, we have our Fx what? Maximum. The body will just begin to move. The body will just begin to move when the applied force is equal to the static frictional force. At this point, we have the limiting frictional force, right? Okay. Now, if Fa is equal to Fs, the body will just begin to move. Like I gave an instance. Let's say if I have my Fs to be 2000 Newton. If Fs is 2000 Newton, that means that for me to move this body from one point to another, the applied force should be greater than or equals to what? 2000. If the applied force is 15, will the body move? No, the body will not move because the applied force is less than the static frictional force. So for this body to move, the applied force must be able to overcome the static what? Frictional force. But there is a point whereby Fa, if Fa is 2000, for instance, what you notice here, the applied force is equals to what? The static frictional force. The body will just begin. That's why we define static frictional force as the maximum force that must be overcome so that a body can just start to move over another. When a body start to move over another, at that point is that Fa is equal to what? Fs. That static frictional force we have there becomes what? The limiting what? Frictional what? Force. Now, when Fa is now greater than Fs, let's say if Fa is now 2500, what do you notice? The body will start sliding. At that moment, the body is sliding or moving, the body now possesses kinetic frictional force. Kinetic means it is a frictional force that acts on the body while the body is in motion. Are you there? So when Fa is greater than what? Fx maximum, the body will gain what? Fk, right? The body will start sliding. Sliding occur or motion occur when Fa is exceed what? Fs. Right? Now, but when the applied force is now equal to, don't forget that when it exceeds Fs, the body now acquire what? Fk, kinetic. But there will be a point whereby Fa will be equals to what? Fk. When the applied force is equals to what? The Fk, the body will start moving with a constant velocity. The ball will start moving with a constant what? Velocity. when FA equals to what? FK. Now, what do you notice? What if at some point the applied force is now removed as the body is moving? If the applied force is removed, that means the only force acting on the body is only what? Kinetic frictional force. Is that not somebody? If this force is present, if I should remove the applied force, it means only Fk will be present. That means the body will be caused to stop. As the body is moving, the body must have to stop. There must be a retardation. There must be a negative what? Acceleration when the applied force has been removed. But when the applied force is equals to what? Fk, acquired by the body as the body is moving, the body will have to move with a constant speed. But when Fa, the applied force, is now removed, let's say I remove the applied force from the body in motion, the body must have to stop. At that moment, the body is moving without the applied force. The only force acting on the body is to cause the body to stop, which is the frictional force. Are you there, somebody? Now let's go. The question now says that a body of mass 12 kilograms is moving with a constant velocity of 5 meters per second on a horizontal surface. We are not told our mu k is 0.2. Question says, what horizontal force is required to maintain the motion? Meaning, since the body is moving with a constant velocity, like we just saw, at constant what? Velocity. We have applied force, right? Applied on the body. There is a force here opposing it. Don't forget, some is along the S-axis, because this is horizontal, is equals to what? The applied force minus the frictional force, all equals to what? MAS. Excuse me. Okay, let's proceed here. Since the body is moving with a constant speed, we are saying that A is equal to what? 0, AB? So here becomes sum of all forces equals to what? Applied force minus what? Fk equals to what? 0. Now, this is why I say that when the body moves at constant speed, the applied force must be equal to the frictional force, the kinetic frictional force. If A is 0, here becomes 0, right? By the time we move this minus Fk to the other side, that means our Fa is equal to what? Fk. For this kind of diagram along the horizontal axis, don't forget that we define frictional force as what? Mu x what? R. Where R is equal to what? Mg. That means for my Fk becomes what? Mu k mg, because R is what? Mg. This time around, the value of R is not what is it called? Mg cos theta, like we saw under incline, because this is not an incline problem. This is just a horizontal surface problem. So that means the whole of this should be equal to what? Mu k what? Mg. So that means our applied force is equals to what? Fk equals to, our mu k is given as what? 0.2 times the mass of the body is given as 12 times gravity is 9.8. Let's multiply out to see what we are going to arrive at the end of the day. So we have 0.2 times 12 times 9.8. This is about 23 point what? 52 Newton. Sorry. So FA is equals to what? FK, right? Equals to 23.5. So the force needed to maintain this motion is about 24 Newton. All right. Now the next question says that. If the force is removed, how soon will the body come to rest? If the force is removed, how soon will the body come to rest? How soon will the body come to rest? Meaning time. We are looking for time. When will the body come to rest? When the force is removed. I says we are looking for time, right? Which is how soon. Sorry. How soon will the body come to rest? Don't forget that, listen, that when the force is being removed, when the force applied is removed, that means that the only force acting on this body is what? Is Fk. In this case here, how soon will the body come to rest? That means the body still is moving. No longer with a constant what now? Velocity. Right? Because we have removed the applied force. The only time we have constant speed is when the applied force is equal to Fk from this expression here. So when the applied force is removed, right, the body must have to come, because frictional force will keep on opposing until the body will come to what? To rest. So that means that the sum of all forces acting on the body, if I'm to remove my Fa, what will remain here is what? Is minus what? Fk. All equals to what? Ma what? X. At this point, A is not what? 0, because the body is coming to rest. So that means that from here, don't forget that the value of our Fk is 23.52. Can we say this is same as minus 23.52 equals to the mass of the body is given as 12 times acceleration. From here, we can find our acceleration from here. So that means my acceleration becomes what? Minus 23.52 divided by what here? By 12. So acceleration of the body is given as, let's calculate this together. 23.52 divided by 12. This is about minus 1.96 meter per second square. Are you there? What do you notice here? We have a negative acceleration. Of course, as the applied force is removed, the body will start slowing down. That means there is a deceleration that will cause the body to come to rest. So the value of A is meant to be negative because the applied force are being removed. So the body must have to decelerate until it comes to rest. All right. Okay. Let's go. So here we have retardation, right? We have retardation of the body. How soon? From equation of motion, we have that V is equals to U plus what? AT. From here, we can be able to determine our value of our time, right? We are given that our initial speed is what? 5 meters per second. For the body to come to rest, final speed must be equal to what? 0. So note that V is equal to what? 0. When the body comes to what? When the body comes to rest. So if V is equal to 0, let's see what we are going to have as our time. That implies that 0 equals 5 plus, we have our A as minus 1.96, right? Times what? T. So this will give us, by the time we move this to the other side here, we're going to have minus 5, right? Equals what? Minus 1.96 times T is what? Minus 1.96 T. So from here, our T becomes what? Minus 5 divided by what? Minus 1.96. Minus can divide minus. So our time is equals to what? Let's divide and see what we are going to have. Our answer is about 2.55. Please take from me and tell me if this is correct from the comment section. Our time is about 2.55. That is our time. Next question. Next question. Please indicate from the comment section if you are following. Indicate. If you are following, please indicate from the comment section. Please, if you are following, please indicate. This is already 12:01, right? Wow, we have really spent so much time here. I will soon be ending this class. Just make sure you indicate. We might not solve all at the end, but at least we have been able to achieve one or two things, right? Let's solve 11.8, the last question here. Then after this, we can stop, or we look at the next topic for those that will be able to continue. The last question says that a block slides down an inclined plane with an initial speed of 3 meters per second. Initial speed is 3 meters per second. The plane has an angle. The angle there is 20 degrees with respect to the horizontal. And we are given the coefficient of kinetic friction is equals to 0.67. The question says, in what distance does the block come to rest? In what distance does the block come to what? To rest. In what distance does the block come to rest? Now let's solve this together and see what we're going to achieve at the end of the day. The answer in the textbook says distance is 1.6 meters. Let's take this out. The question says that a block slides down an inclined plane. This is the inclined plane here. The angle there is given us 20 degrees. This is the block here. We don't know, we're not given the mass of the block. Okay, let's proceed. It slides down the inclined plane. Okay, since the block slides down the inclined plane, don't forget we have a force here called what? Mg, right? And we are told that mu k is 0.6. That means this plane has a rough surface. If it's sliding down, this is my direction of what? Of motion. That means Fg is positive, while Fk is what? Negative. Abi? Fg is positive, Fk is what? Negative. So sum of all forces will then be what? Fg minus what? Fk all equals to what? Ma. So don't forget that the value of our Fg is mg sine theta minus Fk is mu k mg cos theta all equals to what? Ma. Right? Okay, so let's finish up this. The first thing we need to do is to find the acceleration of the body as the body is sliding down the plane. Between this, what is common is mass. Mg is common here in brackets. We have sine theta minus mu k cos theta all equals to what? Ma. Mass can cancel out mass from here. We are left with A equals to G sine theta minus mu k cos what? Cos theta. So let's fix our values and see what we're going to have at the end of the day. Our A becomes G is 9.8 times, here we have sine. Our theta here was 20 degree minus our mu k was given as 0.67. 0.67 times cos 20. Let's evaluate and see what we are going to arrive at. At the end of the day, so here we have 9.8. Acceleration equals 9.8 in brackets. Sine 20 is about 0.3420 minus, let's evaluate this, cos 20 times 0.67. Cos 20 times 0.67 is about 0.6296. So acceleration becomes 9.8 times. Let's subtract this minus 0.3420. This is about minus 2876. Okay, so we are multiplying this, right? This is multiplying this, and that will give us what? Times 9.8. So acceleration here becomes minus 2.8184 meter per what? Second. Okay. The negative sign shows that the block is slowing down. It's coming down the plane. So the block, instead of the block to accelerate up, is now retarding. Okay, it's coming down the plane. So we have a negative value. All right. But the question said, how soon? How soon? Right? How soon will the body come to rest? Okay? How soon will the body come to rest? We have to find how soon will the body come to rest. So how do we solve this? Say form, we have equation of motion, right? Equation of motion, we have about three. What is the first one? V equals U plus AT. We have S equals UT plus half AT squared. Then we have V squared equals to U squared plus 2AS. I can't use this because I don't have time. The only one I can use is this, right? How soon will the body come to rest? But for the body to come to rest, final speed must be equal to what? 0. Don't forget. So using V equals to what? U squared rather equals what? V squared rather equals U squared plus 2AS. Yeah, value of V is equal to 0 because the body comes to rest. So that means that we have 0 squared equals our speed is given as 3, right? 3 squared plus 2 times. We have a negative acceleration, which is minus 2.8184, right? Okay, times our distance. So here, 3 squared is 9, right? I can move this to this side, becomes minus 9 equals, let's multiply 2 times minus 2.8142 and see what we are going to have at the end of the day. 2 multiply with 2.8142 times 2. This is about, no, we have moved this 9 to this side. 0 squared is 0. When you move, becomes what? Minus 9. So we have minus 5.6368. So from here, minus can go with minus times this times. How soon? How soon? The question says what? Is that how soon or how far? Sorry. In what distance does the body come to rest? Sorry, in what distance? So our aim is to find distance, not how soon. In what distance does the body come to rest? Okay. So that means our distance here becomes what? 9. So to find distance, I'll divide both sides by 5.6368, right? So 9 divided by what? 5.6368. Let's take our answer. Divided by 9 divided by, this is about 1.5966, which is same as 1.16 meter. So, hope you understand what happened here. V square equals V square plus 2AS. Our V is that because the body comes to rest. In what distance? On equation, does the body come to rest? So that means that V is equal to 0. So U is given as 3. 3 squared is 9. When you move this 9, becomes what? Minus 9. Minus 2.8184s times 2 will give us this, right? Then minus cancel minus, then distance equals to what? 9 divided by 5.6368. And that is about 1.6. So our answer is corresponding, or it corresponds with what we have here. Okay, guys. Please, if you are still following, show that you are following. Please, in the comment section, please mention that you are following. If you are following, please indicate. Indicate that you are following. Please indicate. Indicate that you are following. Okay, Emmanuel. Okay, Austin is following. All right. Thank you, Sarah. Thank you so much. Chris, I can see you online. Thank you guys, thank you. I really appreciate every one of you. Okay, let's see what we have here again. Let's solve 11.7. 11.7. For 11.7, I will just give the formula, then we apply it. Okay, then we apply it. I won't derive any formula. Okay, so now we can be very fast on this. All right, the next question here, I want us to look at. I hope the board is clear. I hope the board is clear. "11 points. The next question. If the coefficient of friction between tires and road is 0.48, coefficient of friction between tires and road is 0.48. What is the shortest distance in which an automobile can be stopped when traveling at 80 km/h? I repeat again. If the coefficient of friction between tire and road is 0.48, that means that should be our mu x. That's our static frictional force. Okay, between tire and road is 0.48. What is the shortest distance in which an automobile can be stopped when traveling at 80 km/h? 80 km/h. So our initial speed is given as 80 km/h. Now the first thing we need to do is to convert this first to meter per second. Speed, the unit of speed should be in meter per second, not in km/h, right? But don't forget that this is also same as 80 km divided by what? 1 hour, right? 80 km divided by 1 hour. So to convert, I will convert my kilometer to what? To meter. Then 1 hour to what? To second. That means our speed here becomes what? To convert from kilometer to meter means I'll multiply this 80 by 1000, right? Divided by, to convert 1 hour to second simply means multiply 60 by what? 60. So the initial speed here, when you multiply 80 by 1000, that will give us 80,000 over what? 36, right? The final answer here, the initial speed here, is simply about, let me confirm, 22.22, 22.22 meter per what second. Okay, now the question says, what is the shortest distance in which an automobile can be stopped when traveling at 80 km/h? Shortest distance. The formula here says, formula, I would have loved to derive, but let me just show us the formula. It shows u squared divided by 2 mu sg. U squared divided by 2 mu s what? G. This formula is gotten from work energy theory. If you're my student, we have learned work energy and power, right? And we also looked at work energy work theory. Work energy theory says that the total work done or work net is equals to what? Change in what? Kinetic what? Energy. change in kinetic energy, right? And that means what? My total work net is equal to what? KE final minus KE initial, right? KE final minus KE initial. Is that not? Okay. For the automobile to come to rest, to stop, that means our final energy must be equal to 0. If my final speed is 0, for the body to come to rest, which of these expression has the final speed? Is KE final, because KE final is actually half what? MV what squared. K initial is what? Minus what? Half what? MU squared. Don't forget. So from here, when V is 0, we are left to what? Just only minus half MV squared. That means for this question, the work net is equal to what? Minus what? KE what? Initial. Okay? And work is force times what? Distance. I'm not trying to derive it. Me that said I will not derive. I'm not deriving it. Okay, let's just derive and see. Let's derive the formula for this. Work is force times distance. But the force here, since we are dealing with our static frictional force, so the force says what? Is static. Okay? Work is force times distance. So the work done we are talking about here should be the static what? Frictional force. Fx times what? Distance. Work is force times distance. This is the distance here. For the body to stop, for the car to stop, the car must possess a static what? Frictional force. That means the work net, the work done by the static frictional force is called the work net. This work net here is force times distance. It is the static frictional force that is responsible for the work done on that moving car. So that means our work net should be Fs times distance, which is equals to minus what? Half what? M what? MU squared. Because, listen no, because I hope you are aware that static frictional force or frictional force will always do a negative work. We always do a negative work, like we saw under in work energy and power. After this topic, we're going to work energy and power. Frictional force always do a negative work. Work done by friction is always negative, but work done by applied force is always what? Positive. So I can as well put my minus sign here and cancel out this, right? Is that clear? Or rather, just remove the minus sign. If I have minus here, my work net is meant to be minus Fx times what? Displacement equals to minus MU squared. Okay? Or rather, just remove the minus sign to show that we are dealing with what? A work net equals what? Half MV squared, half MU squared. Absolute value for work net equals to what? Absolute value of what? Kinetic what? Energy. Initial kinetic what? Energy. So from here, we can see that our Fx is given as what? Mu xr, right? Of course, mu xr or Fx equals to what? Mu x mg, because r equals to mg. So I can replace this with mu x mg times what? X equals to what? Half mu square is same as what? Mu square over what? 2. By the time we now cross multiply this, 2 times mu s mgs will then give us what? 2 mu x mgx, right? Of course, all equals to what? Yeah? Mu squared. From here, mass can cancel out mass from here. What do you think is remaining? If mass cancel out mass, what then will be our distance? Distance becomes, to find distance, I will divide both sides by 2 mu sg, right? That means my distance becomes what? U squared over what? 2 mu s, 2 mu s g. Yeah, 2 mu s g. Is that not? Now, are we seeing how we can derive this? In case we are asked to derive, maybe in the exam, please pardon me, just take note of this, okay? We start from the work energy theory. From here, then get to this point. Okay? Now, can we now solve now? Let's solve. Let's find the shortest distance. The shortest distance can be solved by, let's input our value. Our initial speed we evaluated is what? 22.22. 22.22. All what? All squared. All divided by 2 times. Our mu s is 0.48. 0.48 times our g is about 9.8. G is about 9.8, right? By the time we apply, that will give us x equals 22.22 squared. Let's solve together. 0.22 all squared. That will give us about 493.7284. All divided by, let's evaluate the denominator. 2 times 0.48 times 9.8. This is about 9.408. So let's divide 493.7284 divided by 9.408. Our shortest distance is about 52.48 meter. Final answer. This is very simple. This is very simple. All right? Please, if you are following, in the case that you are following, okay? I think we are almost done with this. We're almost done. We're almost done. Let me check if the other thing. Okay, look, this question from your textbook. The last question, then we close for today. We close for tonight. Then tomorrow, we conclude on friction. Dynamics of connected bodies on an inclined plane. Dynamics of connected bodies on an inclined plane. Okay? Now, this question says, a car moves along a straight horizontal road. This is your assignment. Please make sure you solve this. All I just need from you is to send the answer into the comment section. Just solve and make sure you post your answer into the comment section. It must not be now, it can be tomorrow or anytime, but it should not exceed tomorrow. Okay. A car moves along a straight horizontal road with a speed of 42 meters per second. What is the shortest distance in which the car can be stopped? What is the shortest distance in which the car can be stopped? I repeat again, assignment. A car moves along a straight horizontal road with a speed of 42 meters per second. The question says, what is the shortest distance in which the car can be stopped, given that coefficient of static friction equals to 0.7? What is the shortest distance in which the car can be stopped? So please solve this problem and send your answer in the comment section. Shortest distance formula, don't forget, this is our formula here. So when you solve, make sure you post your answer in the comment section. All right, we are done for tonight. Okay, so we meet tomorrow again by this same time by 10 p.m. We might likely meet on time tomorrow, although I'll post the class updates. We might be meeting by 8 p.m. But if there will be any adjustment, I will still let us know. Please, if you have any question, you can always drop it in the comment section. So good night, guys. See you tomorrow in class. For those of you that will love to join us in our tutorial, we're having a physical class tomorrow. We're having 5 hours shutdown in chemistry and physics tomorrow. 5 hours shutdown. We'll be looking at both physics and chemistry. Physics and chemistry tomorrow, 5 hours class. And the class is starting by 10 a.m. in the morning. Okay, so see you there at EMI-BRAIN Tutorial College. Thank you, guys. All right, guys.